Guys, stay tuned. You're looking at the solar wind speed charts that is live. Right now we're seeing a bump right here, and it is 7:06 on the East Coast. Remember, in the model timing, we were saying the center of that window of opportunity of impact would be at 7 p.m. on the East Coast tonight. And if you notice, and maybe a little hard to see, this gold line, guys, represents the solar wind speed. The green line represents the temperature of that decrease or increase in solar wind. And the orange line, guys, represents the density or the thickness of the protons in the wave that makes it more powerful or less powerful. Now, something very interesting in the top line up here, and this is a new model, they just changed it, is you see you've got what's called the BT and the BZ lines, and what it does, it represents an opening in our shields. When you see the red and white lines this close together, the shields are closed. And sometimes you'll see a bump that lasts a few hours, like through here, and it's very it kind of jumps around. You have open shields, but here yesterday we had over 12 hours. It was very hot of completely open shields, letting a lot of X-rays in, letting a lot of heat in, radiation, the whole 9 yards. Now today it's a little calmer, but again, we're seeing them come back together. But this indicates a large opening, and that is always due to solar wind speed. So again, we're starting to see this bump. Now it may rise in a step up pattern, or it may just continue into a brick wall. But I wanted to come in, guys, and again, the models are getting more and more accurate as we watch these events. So what we're going to do, if we're looking at 7 p.m. on the East Coast, you realize that the West Coast of Hawaii, the Aleutian Islands, Japan are now getting into daylight, right? Of course, the West Coast has a few more hours, but then you get to Hawaii and Japan, they are becoming totally exposed. And now we never know exactly what's going to happen. If a solar flare comes from the top of the sun, guys, it's so large that that would affect the northern hemisphere a little more than normal, and the southern hemisphere the same way, or completely miss us, or go left or right. All of those factors have to be included if you're trying to watch things like this. But we've been doing it since the quake in Japan in 2011, documenting it. Now let's take a look at our tracking model. It looks very similar to last night, maybe exactly. It looks like there were a few tweaks in it because it gets further in time, you get to look at it a little more. Now what we're seeing, guys, if you look at the color scope here, plasma density, so radial velocity, which is solar wind speed, blue is, the lower volumes of it, and you get up in white, then black. And if you notice the very center of this flare, and I'm going to pause it so I can use the speed myself. Right here, Earth is in the green dot, the sun is in the yellow. This is stereo A satellite. But notice this density section right here is the thickest. But there's good news, and if we look at, this is a top-down view. Well, let's look at it from the side, and you'll see that it's going to be slightly below us, which is a good thing. But the timing is matching pretty much what we said. It's saying here just around midnight on the 3rd, but in Europe, which we're talking about now, the 6 and 7 o'clock hour here in the U.S. as far as the East Coast. Now, again, I'm going to play it through. Our timing is good. Play it through and let you watch this. Now, again, if you look at this section right here, this meridial slice is what they call it. You'll notice the energy here, like these two big puckered up pink lips, is going just below the Earth. Guys, let's play it through, which means a lot. But these models can be slightly off, and I've seen it before. I'm not trying to panic anyone, but I have seen them show not much of an impact, and then we get a dead hit. So you have to watch it. Again, here comes the energy. From the top view, you look like you're pretty encountered, but they have two views. Same thing with the solar wind speed here. You see the top view, then you see the side slice. So let me move it, let me manipulate it. Right here, let's watch this. It looks like an impact. Right here, you can tell the center of the impact is slightly south. Now, you remember one of those flares was in the southern hemisphere of the sun, right? Okay, so here, watch the Mick Jagger Pink Lips from the album. Right there, the impact is going just south of the sun. But look, you see these two spikes right here that we're not missing? You see these two spikes right here in the impact, and the second one is more intense than the first. And again, don't forget, we track these with earthquakes. You never know, but pressure will be applied. Now let's move to a very current image also, guys. This is the Earth-facing side of the sun. And what we're looking at are the two, excuse me, I bumped my mic, but the two sunspots here. Now, if you drew a line right across the center, this would be the northern hemisphere of the sun, and the larger, more powerful one is in the southern hemisphere. And because of the curve of the sun like this, if you're in this area, it's going to blast more upward. Here, it's going to blast more downward. Thus, you're seeing those double waves we just looked at, possibly moving as far as the very center of impact below the planet. But again, this tells you the intensity of the solar cycle. This is a very large system, guys. I did a chart one time comparing the actual size of the Earth to the sun, and it would take 119 of our planets to just cover this side that you're looking at. It's amazing, isn't it? These sunspots are bigger than our planet. If there was a big vacuum, our planet could easily go through any of these blue or red holes with no problem. It's gigantic. Thank our Father it's in his perfect balance to keep us from getting too hot or too cold that he put it 93 million miles away from us. He knows it was a perfect balance. Now, I'm not going to drag this out long again. I'm going to give you these links. Something I forgot to mention, though. When we see this opening in our shields, again, you got different magnetics. The angle of the solar wind coming in can open it or close it. The power of it also can, too. But what I did not mention is this is where we get the most brilliant auroras. So for you guys that can see them, and when they're this strong and this open, you see them further north. And this is a lot of energy coming in. But again, these openings do indicate that the auroras will be very bright. Now, all of the links, just about 99% of the time I put in my videos about space and earthquakes and all, are on our website at bpearthwatch.com. Don't forget that. There's maybe 30, 40 links having to do with this. But what we're looking at now is the live events of the USGS earthquake situation. And so I watched this as we see the incoming solar flares come in, and I did it when the quakes hit Venezuela. I've been doing it again since 2011. So it's another link, guys. All you got to do is go to BP Earth Watch. I think the very top link on the left is earthquakes out of all of them, because it's really one of the most crucial things when you look at Venezuela. And then it goes down through your solar events and all that. But anything that I may leave out, even the images of the sun, things like that, all of those are there. But if I leave something out, you probably can find it there. But all we're seeing right now, we'll click this over to largest magnitude first. We're getting nothing beyond a 5.3 in the South Sandwich Islands. You see that? Most of it is not around us right now. Here's Japan and all. But if you're watching this, again, remember what I said. If you're looking at the solar wind speed, it is universal time. All scientific data comes in that way. So here, this timing, and this is kind of, a teaching thing also. When it says 002317, guys, that is less than an hour before midnight UTC. But anyway, you always see that universal time. That's on every chart. And if you want to track, does this earthquake hit when the solar flare hits? Is that true? Could that happen? Things like that. It does happen. It's been happening for a long time. But that's how you would track it. But right now, we're pretty calm. I've seen a few quakes along the Ring of Fire like we normally do. Maybe because it's diving deeper under the Earth or below our orbit, it won't get intense like we saw before, okay? The strongest thing, probably one of the stronger ones, are here, 5.2 off Greek. In that particular fault line, guys, runs right through Israel, right through here. And if Christ was going to split the mountain, he knows exactly where to step. Comes right through here, cuts right back down through here. Anyway, not far. We've seen history made in this with great quakes, great volcanoes, entire sections of continents sinking down. You know, think about it. Anyway, I'm not going to draw it out, and here's my mama husky over here fussing. She wants a snack. But I wanted to come in and give you this and give you the link. I'm going to be watching too. If we get up some major changes, I'll come in. But I'll give you the tools so you can watch it yourself, guys. Again, we love you. Our Father loves you. It's a major heads up. Be safe. Again, watch for the quakes. If you're in a quake-prone area, keep it in mind, especially now that we're seeing it. The sun is not, it's not dark here. It's 6:30. Still got some angled sunlight. It's not right over us, but the West Coast is different, and also all the way across the Pacific Ocean. Think about the area that I'm telling you about. So if you're in those areas, just keep it in the back of your mind, or you have friends or family, make sure they're aware of it. I know some people may say, that's stupid. Solar flares can't cause quakes. I proved them wrong in 2011. I have done it since then. But the reason I did it is so we have a upfront alert system. Again, we're watching it, guys. You watch it. It's a heads up. Be safe.